So we've moved further into AP Physics. We're now in Unit 4, which talks about energy. And this video is just going to talk about all of the different kinds of energy that we have. So it's sort of like a flow chart. All right. Energy can take many forms. You can think of like chemical energy when you eat, light waves and other sorts of waves. You have electromagnetic energy. And then you can have just electric energy. And you can have nuclear energy, like from a nuclear power plant. Sound energy. Sound waves carry energy. And then you can have thermal energy. These are the biggest forms of energy that we don't necessarily like encounter all of the time. Thermal energy, though, this is a big one because when you have friction, you lose energy due to heat. And so you'll see thermal energy a lot. Sometimes it's abbreviated TH. All right. In physics, for physics problems in mechanics, the kinds of physics that we're dealing with, there's one big energy that's not on this list, and that is mechanical energy. Now, mechanical energy is made of two different forms of energy. It's made of potential energy, and it's made of kinetic energy. And so if I were to write an equation for mechanical energy, it would be ME equals KE plus PE. Kinetic energy plus potential energy. Total mechanical energy is all of the kinetic energy plus all of the potential energy. Potential energy, this is just stored energy. We can store that energy in typically two forms, in gravitational energy, gravitational potential energy, and we can store it as elastic potential energy. Then kinetic energy also has two forms. We're going to talk mostly about translational. So things that are sliding or moving. There's also rotational kinetic energy. All of these forms, these four forms that I've written here, have equations that follow them. Okay, so gravitational potential energy. Sometimes potential energy, we write it as PE. In a lot of the AP stuff, you'll see it as U. So gravitational potential energy, UG, or you could say PEG, is the mass of an object times the gravitational field strength times the height. This height oftentimes is not an absolute height, but a change in height from one place to another place. Elastic potential energy, U sub S, elastic, or PES, elastic potential energy, that is equal to 1/2 K x squared. We haven't talked about K. This is the spring constant. We'll talk about that more when we talk about elastic potential energy. You also see this spring constant when you talk about elastic force. This x squared, that's just a compression or a stretching. So elastic potential energy is oftentimes seen in rubber bands where you stretch them. And so this would be the change in position, or x squared, or you see it in springs where springs are stretched or springs are compressed. And so this would be our change in position, or x. Kinetic energy, let's talk about rotational first. Rotational kinetic energy, KER, is 1/2 I omega squared. We'll talk about omega when we talk about rotational motion. This is just a rotational velocity, rotational speed. How fast is something rotating? And then I, this is the rotational inertia. It's equivalent, sort of like a rotational idea of mass. It depends on the shape of an object. We'll talk more about that in rotational when we talk about rotational motion. The kinetic energy that we're going to work with the most is translational kinetic energy, KET, which is 1/2 mass times velocity squared. Okay, now that we know all of this, the one big thing to remember is the law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed. It can only be transferred. Now, that idea of being transferred, it can be transferred to another object or to another type of energy. Think about chemical energy. When I eat a big salad or a hamburger, I'm taking that energy that's stored in those chemical bonds, and then I am digesting that food and I'm transferring it to maybe kinetic energy, energy of motion. I guess I didn't say that. Kinetic energy is energy of movement. Okay, so the other idea to another object or type, this idea transferring a lot of energy gets transferred as heat. Or you could think energy can be transferred to another object if I have a ball and it's going across and then it hits another ball and this one would stop and then this one would keep going. Collisions, if you will. The unit of energy is the joule, abbreviated capital J. You can get that idea of what a joule is in a few different ways. Mass, gravitational field strength, height, so kilograms times meters per second squared times meters. So this is a joule. Or you could call a joule, this guy here, is a Newton times a meter. Both of these equal a joule.